So the definition of an absolute value, most of us think, well, it's positive, right? Here's the reason why. The actual definition, the absolute value of x, is the distance from 0 on a number line. So we can also consider that the absolute value of x minus 0. How far away are you from 0? Distance is always positive. We don't see negative numbers on a measuring stick. You know, we can't drive backwards and undo our odometer on our car, right? Distance is always positive. If you see something like the absolute value of the quantity x minus a, that means the distance from a on a number line. So in this next example, let's consider two numbers that are 3 units away from 0. So here's our 0 in the middle. We can look at the number 3. Number 3 is exactly 3 units away from 0. But there's always another number that has that same distance from 0. That's its opposite counterpart. -3 is also 3 units away from 0. So when we are solving absolute values, I want you to keep the definition of mind. Distance from 0. How many numbers always have the same distance from 0? 2. And then you're looking at a positive and a negative version inside that absolute value. So let's consider x equals 5 for a second. The number inside that absolute value, that x, is either positive, in other words, x equals 5, or that number inside that x, the opposite of x, would give us 5. I know we're used to putting that negative over by the 5, but there is a reason for my approach here if we start looking at inequalities and the absolute values. So when solving absolute value equations or inequalities, we will have 2 possible solutions. So for example, in our first equation here, we have an absolute value. So that inside of that absolute value can either be the positive version, x minus 4 equals 2, or the inside could be the negative version of x minus 4 to equal that positive 2. So in the first possibility, when we distribute a positive 1, nothing changes, right? So if we add 4 to both sides, we get x equals 6. Great. On the second one, when we distribute that negative, we get the opposite of x plus 4 equals 2. Subtract 4 from both sides, we get the opposite of x equals -2. Therefore, x equals a positive 2. So we only have 2 solutions. We have 2, and we have, way over here, and we have 6. Notice this is not an interval because we are working strictly with equations. So x is either 2 or 6. That is the weirdest looking braces there. Okay, so again, no interval notation here. If you have other things involved with the absolute value, like here in the next example, we want to get the absolute value by itself first. So we're going to add 1 to both sides. We get 3 times the absolute value of 2x plus 4 equals 9. Divide both sides by 3, so we get the absolute value of 2x plus 4 equals 3. Now we can do our 2 possible solutions, where the inside of that absolute value could be the positive version, or the inside of that absolute value could be the negative version. So basically, you're distributing a positive 1 and a negative 1. Oops, I forgot my equals 3 there on the first guy. So on the first one, distributing a positive 1 does not affect anything. So if we subtract 4 from both sides, we would get 2x equals -1. Divide both sides by 2, we get a -1/2. But in the second solution that we're looking for, we distribute the negative to both. -x minus 4 equals 3. I have too many people only changing the operation. They just change the plus or the minus in the middle. you have to distribute that negative just to that inside of the absolute value. So if we add 4 to both sides, we get a positive 7, divide both sides by 2, and we get a negative 7/2 or a negative 3.5. So both of those solutions, negative 1/2 could be graphed there, negative 3.5 right there. But we would just list those two possibilities, negative 3.5 and negative 1/2. Again, we would use braces, not parentheses or brackets. There is a difference. We're not including everybody in between. It's just those two solutions. All right, guys, that's it for piecewise functions and absolute value functions. If you have any questions, don't hesitate to ask. That's what we're here for. Bye.